Let me tell you a little bit about styrene. Very interesting molecule, and as you can see, we know a whole lot about it. This whole book is all about styrene. And one of the interesting features of this molecule is that it can join to other such molecules into a long chain. And of course, we call that polystyrene. And here's a visual representation of that. This is what is meant by polymerization. We take small molecules, join them together, and we get a long chain. And that long chain has properties that are very different from the individual molecules. So we have polystyrene. Polystyrene can be made into all kinds of interesting products. For example, these. Both of these are made of polystyrene. So what's the difference? The difference is that when you make this one, which is called expanded polystyrene or foamed polystyrene, you blow a mixture of air and pentane into the product as it is polymerizing. So there are tiny, tiny little bubbles in here. And that's why it is not translucent, because it reflects light in a different way. It is very, very light. And of course, we use this because of good insulating material. But therein lies a very interesting, let's call it a magic trick. I have some acetone here. Acetone is a solvent that we commonly use in the lab, and you're probably familiar with it as nail polish remover. But watch what happens when we take the foamed polystyrene and we put it into acetone. Now, isn't that neat? It seems to vanish. Well, of course, one of the fundamental laws of chemistry is that matter cannot be made to appear or to disappear. It can only change from one form to the other. So what has really happened here is that the styrofoam cup. Styrofoam is actually a trade name of a company. It really should be called foamed polystyrene. And what is really happening is that it is just dissolving in the acetone. And that's a very interesting phenomenon. And of course, it can be presented as a magic trick, and I often do that. Of course, I follow through the explanation, because science can appear to be magical until you find the explanation. And here the explanation is that the molecules of solvent get in between the molecules of polystyrene, and that's what causes it to dissolve. And of course, it's still there. If we evaporate off the acetone, we'll have the blob of polystyrene left. But there's something interesting about this demo, other than just presenting it as a magic trick. Polystyrene is very difficult to recycle. It's expensive to transport, especially the foamed variety, because it takes up so much volume. And the technology is difficult to recycle it. But there's a new company, a company in Quebec, that aims at recycling this in a fashion like I just demonstrated here. And they will have drums of the solvent at collection facilities, and the polystyrene will put in there, and then they will just transport it in a liquid version, dissolved. And they take it to a recycling facility. There they evaporate off the solvent, get the polystyrene, and it's a very, very effective way of recycling it. They can also separate out the impurities, because when you filter this, the impurities come out. So we have a real possibility here for an economical way of recycling polystyrene, which so far has not really been found. And it's interesting to note that a magic trick has a real practical application.